Hello friends, today we will be discussing about the isochoric processes. So here first of all we have to understand the meaning of the word isochoric. So it is actually made up of two words, iso and choric. Iso means same and choric means volume. So in an isochoric process we have same volume throughout the process. Okay. So it means that volume of the system is not at all changing. So we will go pointwise. First of all, we see the process condition, that is it has same volume throughout the process. Second, process equation. We actually derive this process equation from the ideal gas equation, that is PV is equal to nRT, where P, V and T are the variables and N and R are our constants. So in this process V is constant, so P by T is equal to NR by V. So here NR by V is a constant, which implies that P by T is also a constant. So third, PV graph or PV curve. Actually curve is also another synonym of the word graph. So here we can see that along the y-axis we have plotted pressure and along the x-axis we have plotted our volume. So in this process the volume is constant. So at pressure P1, V1, the gas was in state 1. So as we are increasing the pressure to reach state 2, we have seen that the volume of the system has not at all changed. The volume was V in state 1 and volume is again V in state 2. Okay. So third part is complete. Now we will switch on to the fourth part, which is the work done in this isochoric process. So we all know that work done is equal to integral of PdV. So as change in volume is 0, so dV is also 0. So PdV is 0, so integration of 0 is 0. So in an isochoric process no work is done. Literally no work is done. So what does that mean? We are supplying some energy. Where is that energy going? So we will see it from our first law of thermodynamics. Okay, what does the first law of thermodynamics is saying? It says that the total energy supplied is equal to the change in internal energy plus work done, which in equation form we can write as delta Q is equal to delta U plus delta W. As here delta W is 0, so delta Q is equal to delta U. That is, heat exchanged is equal to the change in internal energy of the system. All the heat which we are supplying is responsible to increase the internal energy of the gases present in the system. What does that mean? That simply means that the gases are moving much more randomly in the system. Okay, so now we will find the bulk modulus of the gas. We know that formula of bulk modulus is minus dP upon dV by V. Here we have been seeing that delta V is 0, so in the denominator we are having a 0, so bulk modulus is moving towards infinity. So bulk modulus of the gas in an isochoric process is infinite. So what is the specific heat of the gas? We know that delta Q is equal to Nc delta T and delta U is Ncv delta T, where Cv is the molar heat capacity of the gas at constant volume. So applying once again, we will apply the first law of thermodynamics, that is delta Q is equal to delta U plus delta W. So here delta W is 0, so delta Q is Nc delta T, delta U is Ncv delta T. So C is equal to CV. So in an isochoric process, the heat capacity of the gas is equal to molar heat capacity of the gas at constant volume. Okay, this completes our isochoric process. Thank you.